Hi friends, see today we'll be starting the third chapter in our second year intermediate, that is wave optics or physical optics. Okay, third chapter, that is this is also called as wave or physical optics. See, from this MSET we are getting hardly 2 marks. Overall light will be getting around 5 to 6 marks. Overall light, ray optics idi kalipi 6 marks. But in this you will be getting 2 marks, from that you may be getting 4 marks. Overall light chapter will be having 5 to 6 marks. So first of all, before going into the wave optics third chapter or physical optics, let us go to some introduction concept. See, introduction means already we have discussed about in past theories about light. Past theories about the concept of light. Okay, so that is see, we have in the beginning, that is around 16th century, around like 16th century. Okay, so Newton, first person, Sir Isaac Newton, came forward with his theory called as Newton's corpuscular theory of light. Newton's corpuscular theory of light. Okay, and later on, second one, Huygens wave theory. Huygens wave theory of light. Alage Planck's quantum theory of light, and finally Maxwell's electromagnetic wave theory of light. So these are the main scientists in the introduction came forward to explain the concept of light. So out of which let us discuss fastly regarding, because even though it is not so important, because it is there in our syllabus, let us discuss because it may come for 1 mark. So according to Newton, what he assumed is as a particle nature. Light is a particle nature. According to Newton, he assumed that light as a particle. That means just like corpuscles, tiny particles. Okay, just like in your in your biology you will be having WBC, white blood corpuscles, or red blood cells or corpus cells. So what he assumed is light is traveling in the form of small particles. Okay, so he assumed that light is traveling in the form of tiny particles, and corpuscular theory, that is not wave theory. He assumed that it is a rectilinear propagation of light, straight line. Rectilinear propagation of light. That means he assumed that light traveling in a straight line, but later on it was proved to be wrong. Light is having a wave nature, not particle nature. Okay, so he assumed that according to him, rectilinear propagation, that means light is traveling in a straight line and in the form of corpuscles. That is the first one. Second point, what he had told is these particles will have different colors. These particles will have different colors. Okay, and with a different shape. And sizes. These particles will have different colors and with different shapes and sizes. And not only this, they travel with different speeds in the denser medium. These are the assumptions. Okay, later on it may be proved to be wrong, but initially, as initiated, light is traveling. He assumed that light is a particle nature, not wave nature. He assumed like that, assumptions, and it is traveling just like a straight line, rectilinear propagation of light. Okay, and different particles have different colors with different shapes and sizes, and they are moving with different velocity in the denser medium. Third point, he told that the velocity of light, that is speed of light, is more in denser medium. He assumed. That means in denser medium what it assumed is velocity of light is more in denser medium than in rarer, he assumed. Than in rarer medium. But later on again, after the entry of other scientists like Foucault and other scientists, it was proved later on wrong. But initially these are the statements given by Sir Isaac Newton. First one is light is traveling in a particles, straight line. Okay, different particles have different colors with different shapes and sizes. Different speeds they are having in the denser medium. And thirdly, velocity of light is more in denser medium than rarer medium. Later on this was proved to be wrong by other scientists. Okay, so this was the thing given by Sir Isaac Newton. And not only that, he failed to explain, because examination adavachu, what are the drawbacks of Newton's corpuscular theory of light. Okay, so these are also called as the failures of Newton's corpuscular theory. Okay, ఏంటి failures అంటే Newton cannot explain, did not explain clearly. These are the defects. Defects of Newton's corpuscular theory of light. So what were the drawbacks or defects? He could not explain interference of light. He could not explain properly the interference of, that means superposition of light waves. Okay, that one. Second one is diffraction. Okay, diffraction of light waves. And third one is polarization. దీన్ని తెలుగులో ధ్రువణం అంటారు. కాంతి యొక్క ధ్రువణం, polarization of light. So because all these are wave nature, not particle. So therefore he could not explain properly, and these were the drawbacks in Newton's corpuscular theory. Okay, so he failed to explain interference of light, diffraction of light, and polarization of light. This was explained successfully by another scientist later on, that is Thomas Young, by YDX. Later on we will be studying in this chapter YDX experiment, that is Young's double slit experiment. Okay, so later on those scientists has proved regarding this. So these are the main failures of Newton's theory. Okay, let us go to the second, Huygens wave theory. Huygens wave theory. Second scientist, Huygens, H-U-Y, Huygens wave theory. So he also not has given correct statement regarding the theory, because what he assumed is, an imaginary one, that is ether. He has assumed light travels, of course, but he told that medium is required. He told that medium, and it is traveling like longitudinal progressive wave, just like sound waves. But this was wrong. Okay, it doesn't travel longitudinal, it is a transverse wave. Light waves are electromagnetic. So what he has assumed is imaginary concept, ether, one medium. ఇలాంటి మీడియం ఏమైందంటే it is spread entire universe. What he assumed is Huygens, ether in a medium తీసుకొని, imaginary medium, this ether was distributed in the space, in the universe, and light is traveling in the form of some wave fronts. He assumed that light is traveling in the form of wave fronts. So this theory was also later on proved to be wrong, because light travel through vacuum. No medium is required. Later on it was proved by the scientists. So according to his assumptions, ether he has assumed imaginary concept. It is spread in the universe entirely, and in that media it seems light is traveling in the form of longitudinal. But it was proved to be wrong. And he assumed a concept called as wave front. He assumed a concept called as wave front. And it is having three types. One is spherical wave front. Second one is plane wave front. Third one is, okay, spherical wave front. This is obtained by point source of light. Plane wave wavefront, light coming from infinity, that is parallel light rays, and third one is linear source of light, like torchlight or whatever thing, like you can see when a beam of light is coming, straight line, okay, linear source. From this cylindrical wavefront is formed. So these are the things I assumed. That means if you take a point source, okay, so from this what he assumed, these spheres are formed, 1, 2, 3, 4. So from this you can see this is spherical wavefront, and this is a secondary source, and on the secondary source again some wavelets are formed, and these wavelets radius is almost equal to speed into at particular time instant. So when you multiply with speed into time at a particular time, that is the radius, and with that radius you can draw a wavelet on the secondary, and if you draw the tangent for all this, again a new wavefront was formed. This was the assumption given by him, Mr. Christian Huygens. Okay, so you can see here from point source of light, this is what you are getting, diverging. Again spherical wavefronts are two types, diverging and converging. So here you are getting diverging. In the same way you can get converging also. See, same way you can get converging wavefronts. So this is how different scientists came forward with this theory regarding the light. So spherical again internal two types. One is diverging spherical wavefront, and second one is converging spherical wavefront. And అర్థం ఏంటి? See, like this, 1, 2, 3. So here if you observe carefully, so light rays meeting at one point, this is called as converging. Before you have seen light rays going away from the source, this is diverging. So like that he assumed the spherical wavefront, 1, 2, 3. Converging at a point, meeting at a point, all light rays, converging spherical wavefront, diverging from a single source, from point source, it is diverging spherical wavefront. So this is the wavefront explained by Huygens from his imaginary concept ether medium, which is distributed entirely in the universe. తర్వాత రెండవది ఎగ్జాంపుల్ ఏం చెప్పాడు ఆయన, డిఫరెంట్ నెక్స్ట్ టైప్ ప్లెయిన్ వేవ్ఫ్రంట్. ఫర్ ఎగ్జాంపుల్ rays coming from infinity, you can see rays coming from infinity, that is parallel rays, always form plane wavefront in this fashion. Okay, so this is parallel light rays. When parallel light rays from infinity, ekkadi నుంచి వస్తాయి parallel light rays? Already I told in light chapter, ray optics. So it always forms from infinity parallel light rays. Parallel light rays నుంచి వచ్చేది he called it as plane wave front. This is the second one. And last and third one, that is linear source. చెప్పాను కదా, టార్చ్ లైట్ నుంచి లైట్ వచ్చినప్పుడు లీనియర్ సోర్స్. సో ఇన్ దిస్ the wavefront obtained is in the form of cylinder. In this is linear source, which is obtained from some torch light. Okay, you can get a linear, and a beam of light coming outside. So from that you are getting another wavefront called as cylindrical wavefront. So these are the assumptions given by Huygens according to his imagination. Okay, right. Please copy it. Right. So finally, Newton's theory was failed, and also Huygens is also later on it was proved to be wrong. Okay, even though he told it is traveling in wave, but it was proved to be wrong because light is a electromagnetic wave. It cannot, no medium is required. It can even travel through vacuum. So this was proved wrong. Again, it was corrected by another scientist, Foucault, by using his rotating mirror. By using rotating mirror. Another scientist named Foucault, around 1850 or so, I think. Okay, I don't remember the exact year. Around 1850, another scientist called as Foucault, 1850 around. Okay. So what he has assumed, he has taken some rotating mirror and finally he proved the velocity of light v, speed of light is around 3 into 2.99, that is 3 into 10 power 8 meters per second. And finally velocity of light, speed of light is more in rarer medium than in denser medium. So finally what happened, Newton's theory was failed and Huygens theory is also failed. Huygens theory is also failed. ఎందుకంటే ఈయన ఏం చెప్పాడు, క్రిస్టియన్ హైగన్ స్పీడ్కి మీడియం కావాలన్నాడు. మీడియం అంటే ఏంటి, ఎలాస్టిసిటీ, డెన్సిటీ. ఓకే, సో ఈ హెస్ కన్జ్యూమ్ సమ్ ఈథర్ మెటీరియల్, ఇమాజినరీ మెటీరియల్. సో దానికి ఎలాస్టిసిటీ ఎలాస్టిసిటీ ఎక్కువ ఉంటుంది, డెన్సిటీ తక్కువ ఉంటుంది. సో వెన్ ఎలాస్టిసిటీ ఈజ్ మోర్ డైరెక్ట్లీ ప్రపోర్షనల్ టు v, v is more. This formula already we have learnt in sound chapter. న్యూటన్స్ ఐసోథర్మల్ ప్రాసెస్లో ఈ ఫార్ములా చెప్పాను, న్యూటన్స్ మెథడ్లో ఐసోథర్మల్ √E/d, ఎలాస్టిసిటీ ఆఫ్ ద మీడియం, డెన్సిటీ ఆఫ్ మీడియం. సో అగైన్ దిస్ వాస్ proved to be wrong and Foucault successfully done the experiment and also found out the value, that is velocity of light 3 × 10 power 8 meters per second was more in rarer medium, air, vacuum, than in denser medium. So Newton's theory has failed and Huygens theory is also failed. Clear? Then we go to the next one. Next one, that is, we'll go for Planck's quantum theory. Planck's quantum theory. Right. So another scientist we all know familiar, Planck. So he has given a theory called as quantum. Quantum means some packets, just like milk packets. Quantum theory. So what he told, E is equal to energy is equal to h nu. That means energy, the light is traveling in this fashion, in the form of packets. Okay, quantas means small packets. Light is traveling in the form of small packets. Okay, and not only that, he has given equation, famous equation, E is equal to h nu or nu is equal to c by lambda. Here h is the Planck's constant, 6.62 into 10 to the power of minus 34 joule second or 6.62 into 10 power minus 27 erg second. This was the value. C is the velocity of light, speed of light in rarer medium, 3 into 10 power 8 meters per second, and lambda is wavelength, and E is energy. So if you put it in MK system, you will get the value in joules. And if you want in electron volts, you have a factor also. If you want electron volts, this will be 1240 by lambda in nanometers or 12400 by lambda in angstroms. This is the approximation method, okay? And this value is joules. And this is in electron volts. Electron volts లో అయితే వాల్యూ అని సబ్స్టిట్యూట్ చేసిన తర్వాత you will get 1240 by lambda in nanometers. If lambda wavelength is given nanometers, this is the energy in electron volts. The same if lambda wavelength is given in angstroms. 1 angstrom is equal to 10 power minus 10 meters. Then 12400 you have to use. Okay. So anyhow, these are the theories given by different scientists. And later on, one more scientist, that is Maxwell, another scientist, he has given his theory, Maxwell, that is EMW. So according to him, Maxwell scientist, he assumed that he is also successful in explaining electromagnetic wave. Light travels in the form of electromagnetic, that is electric vector and magnetic field vector. I told you in the before chapter also, in light, that is electromagnetic wave, how light is traveling, okay? So assumed in this fashion, this is y-axis and this is z-axis and this is x-axis, I cap. So assumed in this fashion, this is electric vector and this is magnetic vector. So assumed in this fashion, you can see this is magnetic field vector. Okay. Both are perpendicular. Already explained in EMW chapter. That is electric field vector perpendicular to magnetic field vector perpendicular to the velocity. That means what is happening here? Electric is in y direction, magnetic field in z direction, and both are going in same phase along x direction. Okay. So electric field is in this direction, electric vector in y direction, magnetic field in z direction, and the wave is going in x direction. And we have an equation also I given, equation a sin kx minus omega t y. Here x means already I told you along the direction of x, positive. If both are plus or both are minus, negative x direction. Okay. If one is plus, another is minus, then it is in positive x. If x is there, if y is there, it is going in y direction, the wave. Suppose if z is there, it is in z direction. This is wave. Okay. This is wave direction and this is the particle direction. This is particle direction. Particle movement. Okay. This is particle direction. This is wave. Wave is going in function about the function x unte kada x direction, y unte y direction, z unte z direction, and this is indicating the particle direction. Okay na? So like this he has explained the Maxwell. That means light is traveling in the form of electric and magnetic field vectors. Electric is in y direction, magnetic is in z direction, wave is propagating in x direction, I cap. Okay. So these are the different concepts given, okay, by different scientists. Now after the introduction, now let us go still further. These are the small concepts given by different scientists. Now we learn about the interference of light. Now we learn about the interference of light waves. See, already in the sound chapter I told you that be careful. Why? Because in sound what all you will be studying, that is constructive superposition, destructive superposition. Constructive superposition lo maximum solid curve, that means maximum sound is observed. Ikkada maximum light means bright. Alage destructive superposition, sound is decreased. So here the light is becoming dark. So those equations what all I told in the before sound chapter, in first chapter, same equations will be repeating here. Okay, and same thing will be understood. But the only thing is formulas will be changing. Bright band, dark bands will be forming depending upon constructive or destructive superposition. Now let us study about the interference of light. Interference of light. Now what is interference of light? Already I told you, just like sound waves interfering. You have seen in standing waves. Two sound waves traveling in opposite direction, same media, same wavelength, amplitude, frequency, superimpose. The resultant is maximum or minimum. We have studied there. Same అదే విధంగా ఇక్కడ రెండు లైట్ వేవ్స్ లేదా రెండు కన్నా ఎక్కువ కూడా ఉండొచ్చు. Two or more light waves. They are interfering. The resultant is called as interference of light waves. So, for example, this is one wave and this is another wave. Suppose both are interfering here. This is one wave, P wave. This is Q wave. Two waves, one is P wave and Q wave. So both are interfering. Both are interfering here. Okay? So two లేదా two కన్నా ఎక్కువ కూడా ఉండొచ్చు interference లో waves రెండే ఉండాలని లేదు. So when they are interfering, you can see the resultant will be there. Resultant. This is one wave y1. This is another wave y2. So what is the y net here? See, y net means it is a vector. It is obtained by vectorial sum. y1 plus y2. The resultant of these two can be obtained by principle of superposition. అక్కడ కూడా యూజ్ చేసిన సౌండ్లో ప్రిన్సిపల్ ఆఫ్ సూపర్పొజిషన్. దట్ మీన్స్ ద వెక్టోరియల్ సమ్ ఆఫ్ ద ఇండివిజువల్ వేవ్స్ ప్లస్ ఆర్ మైనస్, దట్ ఈస్ ద వెక్టోరియల్ సమ్. y1 plus y2 bar is equal to y net. Because స్మాల్ ఎగ్జాంపుల్ అంటే ఫస్ట్ వేవ్ ఫర్ ఎగ్జాంపుల్ పైకి 10 సెంటీమీటర్స్ అనుకోండి, కిందకి కూడా సెకండ్ వేవ్ 10 సెంటీమీటర్స్ అనుకోండి. వాట్ ఈస్ ద నెట్? 0. ఓకే, సపోజ్ ఫస్ట్ వేవ్ 10 సెంటీమీటర్స్, సెకండ్ ఇది 6 సెంటీమీటర్స్. వాట్ ఇస్ ద నెట్? 10 minus 6, 4 centimeters in upward direction. That is called as vectorial sum. The resultant is obtained by vector y1 plus y2. Like this it is calculated. Okay, now I will try to explain by giving more detailedly the vectorial sum. Okay na? కొంచెం ముందుకు వెళ్తాను నేను. I will try to explain in more detailedly the interference of light. For that what I will do is, for example, I will take one wave y1 a1 sin omega t plus minus, it is up to, because one is in opposite direction. If both are plus, both are minus, opposite direction of the function x. If one is plus, another is minus, plus minus unnappudu positive x direction depending upon the function. See, please make a note. If here minus plus is given, rendu okati plus minus aithe positive side, rendu plus rendu minus unnappudu negative side of the function. This is the direction of the wave. This is the displacement of the wave. This is the displacement of the particle. Please don't confuse. This is particle displacement in y direction. This is wave direction, x direction or y direction or z direction depending upon the function. Alage second wave y2 is equal to a2 into sin omega t plus kx anukundam andaka. Okay na? So one wave I have given as a1 sin omega t plus kx, inkoti a2 sin omega t plus kx. అయితే రెండు ఈక్వల్ ఉన్నప్పుడు వాటి మధ్యన ఫేజ్, దిస్ ఈస్ కాల్డ్ as phase. Actually this is called as phase indicated by phi. సో రెండు ఒకటే ఉంటాయి, ఫేజ్ డిఫరెన్స్ సున్నా. ఫేజ్ డిఫరెన్స్ ఈ 0 కదా, రెండు ఒకటే ఉంటాయి. ఒమేగా టీ ప్లస్ కేఎక్స్, ఒమేగా టీ ప్లస్ ఫర్ ఎగ్జాంపుల్ మైనస్ చేస్తే విల్ బి గెటింగ్ 0. సో సచ్ టైప్ ఆఫ్ సోర్సెస్, okay, is called as coherent sources. Coherent sources of light. So what is the definition of coherent source? If their phase difference is maintaining constant with time. With respect to time, if the phase difference phi is maintaining same when they are traveling, when both the waves are traveling, if the phase difference is maintaining, phi is constant, not changing. If it is changing, then it is called as non-coherent or incoherent source. Coherent source of light. Coherent and enti, phase difference remaining constant with the time during the traveling. If it is not maintaining constant with the time, it is called non-coherent source of light. Non-coherent. That means phase difference is changing with respect to time. So what I will do is, I will change the displacements here. Here I will take, see I am changing, y1 is equal to a1 sin omega t plus kx1 ఒకటి. రెండో వేవ్ y2 is equal to a2 sin omega t plus kx2. So here this is maintaining some phase difference, okay, and I am taking some different values. a1 sin omega t plus kx1 alage kx2. Clear? So here what is happening? For example, here is a point P. This is one wave. Say S1 wave is traveling. Let this displacement is x1. Let one more wave is S2 here. Let this displacement is x2. So make a note here. x2 is greater than x1. This is first wave. Second wave. Okay. They are coming and meeting here. Superposition. x2 is greater than x1. That means there is some phase difference between them. That means there is some phase difference. Because x1 is not equal to x2. I am changing. So when you change in that fashion, what happens to the resultant wave we will calculate now. Okay, please note down. Right, now we will be calculating the resultant here by using the principle of superposition. Okay na, shall we? చూడండి, ఈ రెండు వేవ్స్ ఉన్నాయి కదా. Now x2 is greater than x1 and the sources are coherent. That means phase difference is maintaining constant with the time. సో ముందు ఇది మైనస్ చేద్దాం. y net ఏంటి? y2 మైనస్ y1 అంటే ఎంత అవుతుంది? ఒమేగా టీ ప్లస్ kx2 మైనస్ ఒమేగా టీ ప్లస్ kx1. ఒమేగా టీ ప్లస్ kx2 minus omega t plus kx1. This and this will be cancelled. So k into x2 minus x1. What is this one? x2 minus x1, k into phi. Phase difference. Therefore, phi is equal to k into what is x2 minus x1? Delta x, path difference. Okay, path difference between the two waves. So I can write as k into delta x. Leda phi is equal to what is k actually? 2 pi by lambda. So 2 pi by lambda into delta x. Already is the same formula given in sound waves also. Difference, I mean relation between phase difference and path difference. Here k is called as what? Wave constant there. Or sometimes it's also called as wave number. So 2 pi by lambda into delta x is equal to phi. So this is the relation between the phase difference and path reference of the two waves. So difference మనకి అది వచ్చింది కదా. సో ఫైనలీ ఏమైంది, ఇప్పుడు మనకి డిఫరెన్స్ వచ్చేసింది. దీని యొక్క రిజల్టెంట్ ఎంత కడదాం? y net. ఓకే, విల్ ట్రై టు క్యాల్కులేట్ y net. We'll try to calculate y net by using the simplest method. So first wave ఏంటనుకున్నాం? y1 is equal to a1 sin omega t plus k x1. y2 is equal to a sin omega t plus x2. Okay, so here you are assuming x2 greater than x1. Okay, x2 is greater than x1. Now for this I have to calculate the resultant. So what is y net? That is y1 plus y2. Just now I told you vectorial sum. Okay, y1 plus y2. Vectorial sum. So that is equal to y1 a1 sin omega t plus kx1 plus a2 sin omega t plus kx2. Okay, so those two I am adding there, omega t plus kx1 plus omega t plus kx2. Now you can observe, because the difference is there, now these are in SHM, simple harmonic motion. These are in SHM. You can see the path difference is there. ఒకటేమో x1 ఇంకోటేమో x2, రెండు ఈక్వల్ లేవు. రెండు ఈక్వల్ అంటే both are waves now. Now these are going in SHM. So ఈ రిజల్టెంట్ మనకి ఎలా వస్తుంది? We can go a simple method, that is by using parallelogram law. Suppose the first wave, just now I told you, first wave is a1 is less than a2. అంటే a2 కొంచెం గ్రేటర్లో ఉందని చెప్పాం, because x2 is greater కదా. Here అంటే x2 is more than x1. So I will put first wave as a1. Second wave, this one I will take it as a2, and the difference and the phase difference of phi. Phi ఉంది కదా phase difference. So this is lagging, this is leading by phi. Now by using parallelogram law, you can get a resultant. ఎలా వస్తుంది? Very easy. A resultant is equal to a1 square a2 square 2a1 a2 cos phi. Okay, resultant amplitude. And we also know the intensity formula in sound waves also I have given, 2 pi square f square a square rho v. 2 pi square f frequency constant, 2 pi square, a is amplitude, rho density of the medium, v is velocity of the wave. సౌండ్లో కూడా చెప్పాను కదా మీకు, అక్కడ అవి నేర్చుకున్నవన్నీ మళ్ళీ ఇక్కడ నేర్చుకుంటారు. సో ఇవన్నీ కాన్స్టెంట్స్ కాబట్టి ఇంటెన్సిటీ ఈజ్ ప్రపోర్షనల్ టు స్క్వేర్ ఆఫ్ ద యాంప్లిట్యూడ్ ఆర్ ఇంటెన్సిటీ ఈజ్ ఈక్వల్ టు సమ్ కాన్స్టెంట్ ఇంటూ యాంప్లిట్యూడ్ స్క్వేర్. ఓకేనా? సో హియర్ దిస్ ఈస్ ద స్టాండర్డ్ ఈక్వేషన్, రిజల్టెంట్ amplitude. In the same fashion, when the amplitude will be maximum, because దీని బట్టి ఉంటుంది, when phi is equal to 0 degrees, cos 0 is equal to 1 maximum. So when you substitute here, a resultant square and I forgot. So because resultant square kada, a square is equal to a1 square plus a2 square plus 2a1 a2 into 1 cos 0 1. So this is nothing but what? A plus b whole square. And a1 plus a2 whole square is equal to a resultant square for maximum amplitude. The same way for minimum. Minimum and phi is equal to cos 90 పెట్టొచ్చు. Cos 90 is 0. ఇంకోటి ఏంటి? Cos 180 minus 1. So when you put for minimum value, phi is equal to 180, cos 180 minus 1 కాబట్టి ఇక్కడ 1 minus వస్తుంది. So what is a resultant? a1 square plus a2 square, ఇక్కడ minus వచ్చేస్తుంది, minus 2a1 a2. Again ఇదేంటి? a minus b whole square. a square plus b square minus 2ab. Therefore a1 minus a2 whole square is equal to a resultant, or a resultant is equal to a1 minus a2. The same way here, a resultant for maximum is a1 plus a2, because square రెండు తీసేయవచ్చు, అండర్ రూట్ పెట్టేసి. ఇది రూట్ ఆఫ్ పెట్టేస్తే రూట్ అది క్యాన్సిల్ అయిపోతుంది. సో ఫర్ maximum amplitude, theta should be, phi should be 0, a1 plus a2. For minimum, a1 minus a2. Same thing you can apply for intensity also. Same thing. I am rubbing this equation, please copy it. Okay, same thing you can apply for intensity of the light waves. Please note down. See, intensity ఎలా వస్తుంది చూద్దాం. See, as I said just now, intensity is directly proportional to a square. Apply here. Intensity directly proportional to a square. అలాగే I resultant directly proportional to a resultant. Intensity proportional to a1 square, అలాగే I2 proportional to a2 square. అవన్నీ తీసుకొచ్చి ఇక్కడ అప్లై చేయండి. ఈ ఈక్వేషన్లో is equal to a1 square plus a2 square plus 2a1 a2 cos phi. So ar square resultant ఇదిగోండి. So what happened here? IR ఇక్కడ a1 square I1, a2 square I2 to root a1 root I1 అలాగే root I2 cos phi. So same equations whatever we got in sound chapter, same equations are again repeating here. Same equations are repeating, you can see. Clear? So ఏమైంది ఇక్కడ ఫైనల్గా జడ్జిమెంట్. So here also when phi is maximum 0 degrees, because cos 0 is equal to 1. పెడితే ఇక్కడ ఏమవుతుంది? I resultant for maximum please is equal to I1 plus I2 plus 2 root I1 root I2. దీన్ని I can write in the form of root I1 plus root I2 whole square. I resultant for maximum. A plus B whole square again. A square plus B square plus 2AB. And also we got one value. I resultant maximum root I1 plus root I2 whole square. What is root I1? Root I1 and the A1. From this equation, root I1 A1 plus root I2 and the A2 whole square. So intensity for maximum resultant ఏంటి? A1 plus A2 whole square. చూడండి ఇక్కడ ఈక్వేషన్, ఇందులో ఎంత అవుతుంది? A2 root A2 root I2 is equal to A2. ఇక్కడ చూడండి A2 is equal to root I2. అలాగే A1 ఎంత రూట్ I1. సో ఇక్కడ ఏం పెట్టచ్చు రూట్ I1 బదులు I can get A1. అలాగే రూట్ I2 బదులు A2. So A1 plus A2 whole square maximum. In the same way you can get minimum. That will be A1 minus A2 whole square. ఎందుకు మినిమం అంటే కాస్ 180 degrees. కాస్ అంటే మైనస్ ఇక్కడ మైనస్ వచ్చేస్తుంది. సో రూట్ I1 minus root I2 whole square. A square plus B square minus 2AB. Again root I1, A1 minus A. This is for minimum value of light and this is for maximum value. Clear? So this is how you can apply for the interference of light by using simple method, parallelogram law of vectors. Okay? So maximum intensity, maximum amplitude, even in sound waves you have obtained and also in light waves you have obtained. Now one more case we'll be studying in this one and then we'll go to the experiment. Okay? Experiment in the sense, constructive, destructive key, Thomas Young, famous scientist, how he has performed the experiment we'll see and thereby we'll derive some equations also. Okay na? So last ఏంటంటే ఇందులోని ఇందాక మీకు చెప్పాను కదా డైరెక్షన్ కూడా తీసుకోవచ్చు అది. యూ కెన్ ఆల్సో గెట్ డైరెక్షన్. ఇది A1 A2 కదా, ఇది రిజల్టెంట్ AR. సో మధ్యన ఫేజ్ డిఫరెన్స్ 5 అన్నాం. ఇఫ్ సపోజ్ ఆల్ఫా ఈజ్ ద రిజల్టెంట్ అప్పుడు ఎంత అవుతుంది tan ఆల్ఫా వెక్టార్స్ గుర్తుపెట్టుకోండి. B బార్ A సైన్ థీటా అంటే B బార్ A ఓకేనా. B బార్ అంటే సెకండ్ వన్ సైన్ 5 by A bar plus B cos 5. So you can get tan 5 also, direction of this resultant direction, but from vector method, that is parallelogram law. B bar sin theta by A bar plus B bar cos theta. B bar sin theta అంటే A2 sin 5 by B bar sin theta by A bar. A1 plus B bar cos అంటే A2 cos 5. ఈ ఈక్వేషన్ ద్వారా మనకి డైరెక్షన్ కూడా కనుక్కోవచ్చు tan alpha. If alpha is the angle made by the resultant amplitude. Okay, B bar sin theta by A bar plus B bar cos theta. Same thing. Clear? Right. Now what I'll tell you is, suppose, see we had two equations for resultant. That is A1 square, A2 square, 2A1, A2 cos 5. So first we'll solve for amplitude and then for resultant. Let A1 is equal to A2 అనుకుందాం. Let A1 is equal to A2. అప్పుడు ఏమవుతుంది AR square is equal to A1 square. A1 is equal to A2 కాబట్టి A1 A2 రెండు ఈక్వల్ అనుకుందాం. A1 is equal to A2 is equal to A. If both the amplitude are same, then A square plus A square plus 2AA. So here what I will do, 5 is equal to maximum తీసుకుందాం, లేదా cos 5 ఉంచాలి. ఎందుకు? We'll put cos 5 same. Nothing will happen. Cos 5. So what happened here? Resultant A square plus A square how much? 2A square. Again here 2A square cos 5. A resultant whole square is equal to, take 2A square common into 1 plus cos 5. So in trigonometry, to remove this one, we have another formula for this one. That is 2. In trigonometry, 2 cos square theta by 2 minus 1. This one in trigonometry maths, 2 cos square theta by 2 minus 1. That minus 1 plus 1 get cancelled. So this will be remaining. So 2A square into 2 cos square 5 by 2 is equal to your A resultant whole square. Okay, na? But 2 2s are 4. 4A square cos square 5 by 2. So this is what? Resultant square. If you want amplitude resultant, root over 4A square cos square 5 by 2. So what is this value? We'll get it. 4 ki 2 A cos 5 by 2. So this will be the value if amplitudes are same. The resultant value, resultant amplitude value. And the 2A cos phi by 2, where phi is the angle between, phase difference between the two waves. Clear? In the same intensity kuda cheddam manam. In the same way, let us go for intensity. Copy it? Right. In the same way, let us go for intensity. Okay, this is for amplitudes. Intensity formula inda meeku cheppanu kada. Intensity is proportional to intensity of the wave is proportional to amplitude. So ఆ విధంగా తీసుకుంటే ఇది ఎంత అవుతుంది? A square అంటే root. See here, intensity is proportional to, suppose resultant I proportional to A square 1 1, alage I2 proportional to A2 square. So if you apply here, root అవుతుంది ఇది. ఓకేనా? A square కదా, A square కాబట్టి ఇది బాగానే ఉంది. ఇది IR వస్తుంది, IR. నెక్స్ట్ ఇది ఎంత? A1 square plus A2 square plus 2A1 A2 cos phi కదా. సో ముందు ఈ ప్లేస్లో అది పెడదాం ఫస్ట్. ఇది ఎంత అవుతుంది? A1 ప్లేస్లో I1 plus I2 2 root I1 I2 cos phi. Please note down. So here if you observe carefully, I resultant ఎంత వచ్చింది? I resultant is equal to I1 plus I2. Suppose ఇక్కడ నేను ఏం చేస్తాను, let I1 is equal to I2 is equal to I. Let the intensity are same just like before. So what happened now? I plus 2 root I into I cos phi. So I plus I 2I plus root I into root I. ఎంత? root AB అంటే again I. See, root A into root AB ఎంత అవుతుంది? root AB కదా, I into I square. So I కదా root. So I into cos phi is equal to I resultant. లేదా resultant is equal to, you take 2I common into 1 plus cos phi. Again use trigonometry and remove this 1 here. 2 cos square theta by 2 minus 1, that is cancelled here. So finally 2I into 2 cos square phi by 2. That implies 2 to the 4I cos square phi by 2. So this is very important formula. Sometimes in advanced level they will be asking. Okay. So resultant intensity I of the waves is given by 4I into cos square phi by 2. Cos square, that phi is the phase difference. Phi is the phase difference. Very important formula. Okay, very important. Clear? Okay. Now let us go to the next one, that is famous experiment, that is Young's double slit. Copy it? Copy it. Okay. Next అసలైన దానిలోకి వెళ్దామండి ఇప్పుడు. That is this experiment, and also in MSET it is very important, because I told you mainly we are orienting regarding MSET classes and NEET classes. Okay. So Thomas Young అనే scientist, Thomas Young scientist, this is also called YDSE, Young's double slit experiment. Okay. So what he has done is, he has taken one source, monochromatic source, single color, monochromatic source. Monochromatic అంటే ఏంటి? సింగిల్ కలర్, ఏదో కలర్, విబ్జిఆర్లో ఏదో కలర్. ఓకే, ఒకటే వేవ్ లెంత్ అనమాట. సో ఫ్రమ్ దిస్ ద light is emitted. He has made two slits. S1, S2, and the distance is very minimum, distance D, almost equal to millimeters. That is 10 to the power of minus 3 meters. Almost equal to millimeter. Okay, distance between the two slits. Okay, very small slit, distance D, and he has kept one screen here. Okay, And please make a note, the distance between the screen and the slit D is very larger than small d. That means this is in meters, this is in meters, and this is in millimeters. So as compared with capital D, distance between screen and the slits very larger. Okay, and this is the central line I am drawing. Let P be the point. Okay, now see here, for example, from geometry if you observe, S1P is equal to S2P. P is a point on screen. That means S1 and S2. See, one thing I am telling you, I told you in sound waves, constructive and destructive. I told you the same thing again will be repeating here also. Because already I have derived there. If you want, I will derive the derivations here also if you want it. Okay, if you want it. Because in the sound waves I told in the beginning only what all derivations I have done for constructive. See, for constructive superposition of waves, I mean light waves, and destructive superposition of light waves. మీకు సౌండ్లోనే చెప్పాను, ఆ ఫార్ములాస్ మళ్ళీ ఇక్కడ వాడుకుంటామని. అక్కడ ఏం చెప్పాను ఒకసారి గుర్తెచ్చుకోండి. ఫేజ్ డిఫరెన్స్ ఫర్ కన్స్ట్రక్టివ్ ఏంటి? 0, 2π, 4π, 6π, అలాగే 2nπ. అంటే n వాల్యూస్ ఏంటి? 0, 1, 2 పెట్టండి, n 0 పెట్టండి, 0, 1 పెట్టండి, π. ఇది లాంబ్డా కాదు, π. సో ఫర్ కన్స్ట్రక్టివ్ అంటే మ్యాక్సిమం కావాలంటే, మ్యాక్సిమం బ్రైట్ కావాలంటే 2nπ అండి ఇది. సో వెన్ యూ పుట్ 0 here you will get 0. When you put 1, 2π, 2, 4π. సో దీస్ ఆర్ ద పాజిటివ్ వాల్యూస్ 0 నుంచి n వాల్యూస్. అలాగే పాత్ రిఫరెన్స్ రావాలని ఏం చెప్పాను? పాత్ రిఫరెన్స్, ఫర్ పాత్ రిఫరెన్స్ డెల్టా ఎక్స్. ఈ సందర్భంలో ఎంత వచ్చింది వాల్యూస్ చెక్ చేద్దాం ఒకసారి. సి, phi is equal to 2π by lambda into delta x. ఓకేనా? ఎంత వచ్చింది అప్పుడు? ఫస్ట్ 0 పెట్టండి, 0 into lambda by 2π is equal to delta x. అంటే ఫస్ట్ ఇది 0, సెకండ్ ఎంత అవుతుంది? 2π. చూడండి, 2π into lambda by 2π. 2π గెట్స్ క్యాన్సిల్, lambda. నెక్స్ట్ ఎంత వస్తుంది చెప్పండి? 2 lambda. Next 3 lambda, 4 lambda, n lambda. Please make a note. See, why I am telling directly is because already in sound chapter I derived these equations by drawing some graphs, two waves, y1 plus y2 and y1 minus y2. So here waste of time because I am telling mainly we are concentrating on MSET and NEET examinations. So directly I am giving these formulas. For constructive, the phase difference is 0, 2π, 4π, 2nπ. N values are 0, 1, 2, 3. And for path difference delta x, the value should be 0, lambda, 2 lambda, so on and so forth. Okay na? అదే విధంగా ఫర్ డిస్ట్రక్షన్, డిస్ట్రక్షన్కి ఏమైంది? ఫస్ట్ ఎక్కడ మీట్ అవుతున్నాయి రెండుని? π, 3π, 5π, 7π, 2n minus 1 into π. 2n minus 1. Suppose put value here 0, not valued. So better you take minus. మైనస్ పెడితే ఎంత అవుతుంది ఇక్కడ? టేక్ 1 n వాల్యూస్, 1, 2, 3, 4. పుట్ 1 π, 2 to the 4 minus 3π. So valid. The same way, what is the path reference for this one? Path reference ట్రై చేయండి, ఎంత వస్తుంది వాల్యూ చూడండి. lambda into π, lambda into π by 2π is equal to delta x. ఎంత? π lambda by 2. సో నెక్స్ట్ ది 3 lambda by 2. నెక్స్ట్ ది 5 lambda. ఇప్పుడు 2n minus 1 into lambda by 2. చెక్ చేద్దాం. ఓకే, నెక్స్ట్ ఒక చెక్ చేద్దామా? నెక్స్ట్ ఎంత? 3π, 3π into lambda by 2π, 3π, 3 lambda by 2. సో ఇలాగ మీరు వేసుకుంటే సపోజ్ పుట్ వాల్యూ 0 హియర్, పుట్ వాల్యూ 0, lambda by 2. Put 1. So ఇక్కడ 0 పెడితే మైనస్ వచ్చేస్తుంది చూడండి, 0 పెడితే మైనస్. సో 0 అవుతాం. విల్ స్టార్ట్ విత్ 1. విల్ స్టార్ట్ విత్ పాజిటివ్ వాల్యూస్ 1. సో 1 పెడితే lambda by 2. 2 to the 4 minus 1. 3 lambda by 2. So 1, 2, 3, so on and so forth. Clear? So please make a note, for constructive and destructive, these are the phase difference and path reference. 0, 2 pi, 4 pi, 2n pi, లేదా 0, lambda, 2 lambda, 3 lambda, so on and so forth. ఓకేనా? అలాగే ఫర్ డిస్ట్రక్టివ్ వేవ్స్, లైట్ వేవ్స్, pi, 3 pi, 5 pi, 2n minus 1 into pi, లేదా lambda by 2, 3 lambda by 2, 2n minus 1 into lambda by 2. Now come back to the experiment here. Here from geometry, I will write it here for the better. I will write here 2n minus 1. Okay. Okay, here you can see 2n minus 1 into pi. Phase difference 5. అలాగే path reference delta x 2n minus 1 into lambda by 2. ఓకే, ఇది కన్స్ట్రక్టివ్కి, కన్స్ట్రక్టివ్ ఎంత వచ్చింది మనకి? ఇది కన్స్ట్రక్టివ్ కదా, కన్స్ట్రక్టివ్ ఎంత వచ్చింది? లాంబ్డా. ప్లీజ్ డైరెక్ట్గా వాల్యూస్ రాసేద్దాం. సో బెటర్ ఫర్ ఇట్ బికమ్స్ ఈజీ ఫర్ అస్. ఫర్ కన్స్ట్రక్టివ్ పాత్ రెఫరెన్స్ ఎంత వచ్చింది? కన్స్ట్రక్టివ్ n లాంబ్డా. అలాగే ఫర్ కన్స్ట్రక్టివ్ ఇది అంటే బ్రైట్. అలాగే డార్క్ ఎంత? 2n minus 1 into lambda by 2. 2n minus 1 into lambda by 2 for dark bright. And for bright ఎంత వచ్చింది? 0 lambda, 2 lambda. So రాస్తున్నాను 0 lambda, 2 lambda, 3 lambda, n lambda. Now those are important in the derivation here. Remaining all I will drop it now. Because since I told you in the sound chapter only, because I am omitting, otherwise I would have derived for you. Don't worry. Please see my videos in sound waves, there I have derived. If you want it, the derivation, see my videos in sound waves part 1, part 2 and part 3. There you will be getting the constructive and destructive derivations. So now if you observe it from the geometry, S1p is equal to S2p. And the path reference ఎంత? S1p minus S2p is equal to 0. So delta x is equal to 0. ఓకేనా? సో హియర్ నో పాత్ రిఫరెన్స్ 0 అంటే ఇక్కడ సెంట్రల్ బ్రైట్ ఫామ్ అవుతుంది. అట్ దిస్ పాయింట్ ఏమవుతుంది? సెంట్రల్ బ్రైట్ బ్యాండ్. సెంట్రల్ బ్రైట్ బ్యాండ్ ఈస్ ఫార్మ్డ్ at point P. Clear? So here the path reference is 0. Let us go to the next case. Because here there is no path reference, central bright is at the center point of the screen. Now what I will do is, these are the two slits, S1, S2, and this is source of light, monochromatic, single light. Distance D, this is center point, and this is screen. This is center point, and this is central bright. Okay. Now what happens is, let the point be here now from central bright. Let this angle be theta, and this point from S1 wave, and this is S2 wave. Now if you observe carefully, same thing in the distance between screen, D is very much greater than this D, and this is D by 2. Please make a note, distance between slit is very less compared to capital D. Okay. Now you observe carefully. Ippudu from geometry, if you observe, S1p is less than S2p. So there is some path reference. How to get that path reference? I will do one thing. I will drop a perpendicular on this line. Okay. I will name it as some M. Now from geometry theta కాబట్టి I will extend one line here. If this is theta, this is also theta. Total angle 90 degrees. So what will be this angle? 90 minus theta. This is 90 minus theta, this is 90. So what is this angle? Theta. From geometry. I am drawing here. Okay. This is 90 degrees. This is M. This is S1. This is S2 and this is what? D. So ఈ యాంగిల్ ఎంత అయింది? ఇది 90 మైనస్ థీటా. సో 90 మైనస్ థీటా ఇది ఎంత అవుతుంది? 90 మైనస్ థీటా ప్లస్ 90. ఓకేనా? టోటల్ యాంగిల్ ఎంత ఉండాలి మనకి? 180 కదా. సో 90 మైనస్ థీటా, ఇది థీటా అండి, ఇది టోటల్ 90, ఇది 90 మైనస్ థీటా. సో ఇది ఎంత అవుతుంది అప్పుడు? ఈ యాంగిల్ 90 మైనస్ ఆఫ్ 90 మైనస్ థీటా. బికాస్ టోటల్ యాంగిల్ ఎంత? 90 మైనస్ థీటా ప్లస్ 90 ప్లస్ ఎక్స్ ఇజ్ కూడా 180. సో యాంగిల్ ఎంత అవ్వాలి? 90 మైనస్ థీటా అంటే 90 మైనస్ 90 ప్లస్ థీటా. సో దిస్ యాంగిల్ ఇస్ థీటా. క్లియర్? సో ఇది థీటా అయినప్పుడు దీనికి ఏంటిది? ఇది 90 కదా, ఇది పెర్పెండిక్యులర్. సో దిస్ ఇస్ ఆపోజిట్ సైడ్. So this one I'll assume as delta x. That one I'll assume as delta x, path reference between two ways. Path difference between two waves, delta x. How will get this one? Opposite by hypotenuse. This is delta x చూడండి. Opposite by hypotenuse. That means opposite by hypotenuse is equal to what? Sin theta, or delta x is equal to d sin theta. Clear? So from geometry I got the values here. I am rubbing, please copy it. Right. Now see here, I got delta x value. I got delta, that means path reference. Now as I said for the constructive, that means for maximum అంటే సెంట్రల్ బ్రాండ్ నుంచి నెక్స్ట్ బ్రైట్, ఇక్కడ బ్రైట్ ఫామ్ అవుతుంది, బ్రైట్ బ్యాండ్. సో ఎక్కడ ఫామ్ అవుతుంది? ఫస్ట్ బ్రైట్. విల్ ట్రై టు క్యాల్కులేట్ ఫస్ట్ బ్రైట్. ఎలా వస్తుంది ఫస్ట్ బ్రైట్? ఈ డిస్టెన్స్ ఫర్ ఎగ్జాంపుల్ లెట్ us say y from central brand. Let the p be at a distance y from the central brand or central bright. Now how to get this point here? Already I told you what is the path reference. 0, lambda, 2 lambda, 3 lambda, 4 lambda, n lambda. So leave the 0 first one, go to the second one, lambda. Okay? 0 అంటే path reference సున్నా కాబట్టి ఫస్ట్ పాయింట్ తీసేయండి. Go to second one, lambda. So delta x is equal to lambda for first bright from the central brand. Delta x is equal to lambda, which is equal to what? D sin theta, or lambda by small d is equal to sin theta. Equation 1, lambda by d is equal to sin theta. But here please make a note, wavelength lambda is in angstroms, and 1 angstrom is 10 to the power of minus 8, 10 meters. 1 angstrom ఎంత? 10 to the power of minus 10 meters. That means lambda is very much less than small d again. 10 to the power of minus 10 meters. So ఇదేమో 10 to the power minus 3. ఎవరు పెద్ద? Small d is greater than this one. So lambda is very much less than small d. Because 1 angstrom and 10 power minus 10 ఇది 10 power minus 3 meter. This is more larger. ఇది ఇంకా చిన్నది. So that is lambda is very much less than d. In such cases what we will do is sin theta can be almost equal to tan theta. Now from this triangle you can see this triangle S1 S2 ఏదైనా పేరు పెడదాం దానికి, n p సెంట్రల్ బ్రాండ్. సో ఈ ట్రయాంగిల్ తీసుకుంటే కదా థీటా కదా యాంగిల్. వాట్ ఈస్ tan theta? Tan theta is equal to opposite by adjacent, y by capital D. So just now I told you, when these values are very less, the light rays, because capital D is very much larger, so light rays are very nearer, so angle is very less. less than sin theta is equal to tan theta. Therefore y by d is equal to lambda by small d, or from this what happens, lambda d by d is equal to y. Clear all of you? lambda d cross multiply cheyandi, lambda d by d. So this is called as first bright from the central band. Central band నుంచి ఇది ఫస్ట్ బ్రైట్. అలాగే సెకండ్ బ్రైట్ కావాలంటే సేమ్ థింగ్ అగైన్ 2 lambda, దట్ మీన్స్ 2 lambda d by d. సెకండ్ బ్రైట్ పుట్ ఇట్ హియర్. ఇక్కడ డెల్టా ఎక్స్ ఎంత, లాంబ్డా ప్లేస్లో 2 lambda పెట్టేయండి. డెల్టా ఎక్స్లో 2 lambda is equal to d sin theta, 2 lambda by small d sin theta. This is for second bright. So 2 lambda by d is equal to again this distance tan theta, 2 lambda d. అలాగే third 3 lambda d capital D by small d is equal to third bright, first, second, third bright from the central one. అలాగే if you go on like that, what is for nth one, nth bright band ఎంత వస్తుంది, n lambda capital D by d is, this is for nth bright. Please copy it. These are very very important in solving numerical problems. Clear? Right, copy it. So from this many problems are coming for MSET and also NEET examination. So this is the pattern for, okay, this is the pattern for bright bands. So for bright bands formation, first one ఎక్కడ వచ్చింది మనకి, lambda d by d, తర్వాత సెకండ్ బ్రైట్ 2 lambda d by d, 3 lambda d by d, అలాగే nth bright n lambda d by d. These are first bright, second bright, third bright from the central point. First bright, second bright, third on one side. See, either you can get this side or this side. Both sides you can get bright and dark. Bright వస్తుంది లేదా డార్క్ వస్తుంది అనమాట. Okay, that I'll tell later on in the next videos and other things. Okay, so have you copied all this one? Copied? Right. Now I will give for the dark and then I'll close this video for dark band also. See, dark band మీకు ఏంటి, పాత రిఫరెన్స్ చూడండి ఎంత ఉంది, పాత రిఫరెన్స్ ఎలా వచ్చింది, lambda by 2 చూడండి, lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n minus 1 into lambda by 2. So for dark band, ఓకేనా. సో డార్క్ బ్యాండ్ అంటే ఏంటి, సేమ్ థింగ్ అగైన్, డెల్టా ఎక్స్ ఎంత, డెల్టా ఎక్స్ is equal to d sin theta. Already we got here, opposite by, that is opposite by hypotenuse, that is delta x by d is equal to, ఇక్కడ ఉంది చూడండి చెప్పలేదు, d sin theta is equal to delta x. So this d sin theta will be equal to what, lambda by 2. Therefore from this what happens, sin theta lambda by 2d. So for first dark from the central, okay, ఇక్కడ ఫస్ట్ బ్రైట్ వచ్చింది. సో ఫస్ట్ డార్క్ రావాలంటే అగైన్ సేమ్ థింగ్, lambda by 2d equal to tan theta again, opposite by this end, that is small y by capital D, or lambda d, okay, lambda d by 2d is equal to first dark. అలాగే సెకండ్ డార్క్ ఏమవుతుంది, lambda by 2, 3 lambda by 2, చూడండి ఇక్కడ రాస్తున్నాను. Can I rub this one? Okay, I'll rub this figure. చూడండి. ఓకే, నౌ దిస్ ఈస్ ఫస్ట్ డార్క్. అలాగే సెకండ్ డార్క్ ఎంత వస్తుంది, చూడండి, 3 lambda by 2 డెల్టా ఎక్స్. డెల్టా ఎక్స్ is equal to ఎంతది, d sin theta which is equal to 3 lambda by 2, లేదా sin theta is equal ఎంత అవుతుంది, 3 lambda by 2d which is equal to tan theta, that is y by d. So 3 lambda capital D by 2D is second dark. The same way, third dark 5, odd numbers, 5 lambda by 2D, third dark, and nth dark, 2n minus 1 into lambda capital D by 2D. This is nth dark. Please try to remember all these formulas, because while doing numerical problems, all these are very important, please. Okay? Numerical చేస్తున్నప్పుడు ఇవి చాలా important అండి. So try to recollect all this. When I do problems and when I give problems, you have to do all these things. Okay? So let us summarize one before going to the next thing. Let us summarize. See, I am summarizing all the things before ending this video. So in YDXC experiment, for bright bands, for first bright, ఏమొచ్చింది lambda d by d, second 2 lambda d by d, third 3 lambda d by d, because already you know here delta x opposite by, that is d sin theta. Okay na? Opposite by evidence kada, delta x by d sin theta, and this is equal to what? First one, lambda, 2 lambda, 3 lambda, n lambda. So అది మనం ఈక్వేట్ చేశారు కదా, d sin theta is equal to, okay, delta x is equal to lambda కదా. సో ఇప్పుడు ఎంత sin theta, lambda by d, that is equal to tan theta y by lambda d by d. సో ఇలా వెళ్తే మీకు nth ఎంత వచ్చింది, nth బ్రైట్ 1 2 3 4 5 6 n lambda d by d. This is for nth bright from the central band. In the same way dark band ఇక్కడ చూడండి, డార్క్ ఏమొచ్చింది ఫస్ట్ మనకి ఇక్కడ lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n minus 1 into lambda by 2. సో ఇప్పుడు ఎంత వచ్చింది ఇక్కడ మనకి, d sin theta is equal to lambda బదులు lambda by 2 పెట్టండి. అప్పుడు sin theta ఎంత అవుతుంది, lambda by 2d, tan theta ఎంత అవుతుంది, y by d. సో lambda d by 2d. ఓకే, lambda d by 2d. తర్వాత 3 lambda చూడండి, ఇది 3 lambda d by 2d, అలాగే 5 lambda d by 2d. సో డార్క్ బ్యాండ్కి ఎలా వస్తున్నాయి, ఫస్ట్ డార్క్ lambda d by 2d, సెకండ్ డార్క్ 3 lambda, ఇక్కడ చూడండి ఇక్కడ d వస్తే ఇక్కడ 2d వస్తుంది. అలాగే థర్డ్ డార్క్ 5 lambda d by 2d. అలాగే nth డార్క్ బ్రాండ్ is equal to dark, okay, that is 2n minus 1 into lambda capital D by 2d. So these are the formulas you have to remember, because ఇది గుర్తుపెట్టుకుంటే చాలు, ఇవన్నీ మర్చిపోయిన పనులు. ఎందుకంటే ఇక్కడ n ప్లేస్లో పుట్ సపోజ్ 1 పెట్టండి, ఎంత 2 2 జర్ 2 1 జర్ 2 minus 1 lambda d by 2d. ఫస్ట్ డార్క్ 2 పెట్టండి, 4 minus 1 3 lambda d by 2. సెకండ్ డార్క్ 4 పెట్టండి, 4 2 జర్ 8 minus 1 7 lambda d by 2d. ఫోర్త్, అలాగే ఫిఫ్త్ డార్క్ 5 పెట్టండి, 5 2 జర్ 10 minus 1 9. అలాగే యూ కెన్ ఫైండ్ అవుట్ ఫర్ ఎనీ నెంబర్ వాల్యూస్, డార్క్ వాల్యూస్. అలాగే బ్రైట్ కావాలంటే ఇవన్నీ మర్చిపోండి, రిమెంబర్ దిస్ ఫార్ములా ఫర్ బ్రైట్ బ్రాండ్, nth బ్రైట్ n lambda d by d. 1 పెట్టండి, lambda d by d ఫస్ట్ బ్రైట్. 2 పెట్టండి, n is equal to 2 lambda d by d. 3 పెట్టండి, 3 lambda d by d. 4 పెట్టండి, 4 lambda d by n పెట్టండి, n lambda d. So like that you will get for bright and dark bands. Okay, so what I will do is, in next video, that is part 2 of wave optics or physical optics, I will make some problems for you. I will try to solve problems for you. Okay, and we will go further, right?